So moving on to our final section of the Chapter 8, the Unit 7 that we'll be studying. It's called 8.7 Applications of Right Triangle Trigonometry. So now you're going to read through a problem, try to set up a diagram based on what you read. It's going to be a right triangle. Then you're going to decide if you should use sine, cosine, or tangent to solve for the missing piece of information. Now in this section there are two vocabulary words that are introduced, two new ones, and they are angle of depression and angle of elevation. So let's read and see what that says, or what they are. It says, suppose an operator of a lighthouse sights a sailboat on a line that makes a 2-degree angle with the horizontal line. The angle between the horizontal and the line of sight is called the angle of depression. At the same time, a person in the boat must look 2 degrees above the horizontal to see the tip of the lighthouse. This is the angle of elevation. So let's try to draw that picture. Okay, if this is the lighthouse right here, right? So this is the base of the lighthouse, this is the top of the lighthouse. Then out here in the water, right, is a sailboat. It's going to be really far away if it's only a 2-degree angle. So here's my sailboat. So this is supposed to have a 2-degree angle looking up to this person up here in the lighthouse, right? So there's a little light, flashing, flashing, flashing. Okay. So here is my right triangle. The lighthouse meets the ground at a 90-degree angle. This is a 2-degree angle. But it says, suppose an operator of a lighthouse, that's this guy up here, sights a sailboat. So he is looking down. This is his line of sight right here. Sights a sailboat on a line that makes a 2-degree angle with the horizontal line. So here's my horizontal line, right? So this is the horizontal line. This is his line of sight right here. So it says that this angle is 2 degrees as well. Well, why does that make sense? The horizontal line of sight, or the horizontal line looking straight out, and this line down here are parallel to each other. So what do we know about this angle and this angle? Well, this is the z, right, that parallel line. So those are alternate interior angles, therefore they are congruent. Now, vocabulary-wise, this is the angle of depression. So this was the original angle that was described in the sentence above. So that was the angle of depression. If you're the person down here on the ground and you're looking up, right, so you're down here, you're in the sailboat, you look up toward the guy in the lighthouse, this is the angle of elevation. You're looking up into the air. If you're looking down from somewhere high and looking down, that's your angle of depression. But your angle of elevation and your angle of depression are congruent to each other. So those are the vocabulary: angle of elevation, angle of depression. Make sure you're always making this horizontal line, and then your line of sight is in between. Okay, so it says at the top of the lighthouse is 25 meters above sea level. Okay, so this length right here. So now if I just make a little side note, so here we have it. This is 2 degrees. This is 25 meters. It's top of the lighthouse, bottom of the lighthouse. This is the boat over here. Find the distance x between the boat and the base of the lighthouse. So this is the boat, this is the base of the lighthouse. So I'm trying to find that length. First, sketch a diagram to represent the situation. Round your answer to the nearest tenth. So here's my diagram to represent the situation. I should put a right angle in there. And now you're just going to ask yourself, am I going to use sine, am I going to use cosine, or am I going to use tangent to solve that problem? So with respect to this angle down here in the corner, this is my opposite side, x is my adjacent side, and then of course my hypotenuse is right here. So 25 is my opposite, x is my adjacent, therefore I need to use tangent because I'm relating opposite and adjacent to each other. So tangent of 2 degrees equals opposite, which is 25, divided by adjacent, which is x. Now what do you do if there is a variable in the denominator? Remember the shortcut? You can just switch these places, right? So remember these are proportions. In proportions you can just switch locations right here. So solving, sorry I'm running out of room, I'm going to erase my big diagram. So I'm going to have x equals 25 divided by tangent of 2 degrees. And when you calculate that, you should get 715.9 approximately, 0.9 something. And so the answer is here. It's about 716 meters. Now, if you feel like trig isn't a problem for you, that word problem you just read through wasn't a problem, then I would pause now and try to do 1, 2, and 3 on your own. You can see that here the answers are given. So go ahead and try that on your own. Now, for those of you needing calculator help, remember we had to plug in 25 tangent of 2. So I'm going to go 25, So 25 times tangent, I push my trig button, here's my tangent of 2 degrees. Sorry, it's not multiplication, I made a mistake. I've got to do division here, my fault. Tangent divided by, 25 divided by tangent of 2 degrees. This is what I just wrote on my paper. I push enter. Remember, for the TI Inspire, you have to push second enter. And what do I get? I get 715.906. If I was rounding up to the nearest meter, it's around 716. Okay. So moving on, either pause, do them on your own, or do them with me now. Okay, when the sun's angle of elevation is 38 degrees, a building casts a shadow 45 meters. Okay, so here's the building. This is 45 meters. If I put my sun over here, that means it's going to cast a shadow. So already I've made a mistake. Okay, here's my shadow right here, and it says the building casts a shadow of 45 meters. So this is the 45 meters. Sorry about that. This is the height of the building, right? So this is the building. How high is the building? So how tall is the building? How high, maybe how tall is the building? Okay, well I have this length of 45, and then I have an angle of elevation of 38 degrees. So your angle of elevation of the sun's angle of elevation, that means from the ground, if you were looking up, or how does the sun meet the ground? That's this angle right here. From the ground up, so that's 38 degrees. Again, which trig function do you notice we are using? It's the opposite. With respect to this angle, this is the opposite side, this is the adjacent side. So once again, I'm using tangent. Tangent of 38 degrees equals opposite divided by adjacent. So x divided by 45. I multiply each side by 45. So 45 times tan of 38. And again, I would do 45 times tan of 48. Let's see, 45 times tan of 38. I thought I said that wrong. Control enter, I get 35.16, so this says about 35 meters. So it's about 35.2 meters. Okay, next. From the top of a lighthouse, 20 meters high, a sailboat is sighted having an angle of depression of 4 degrees. So here's my lighthouse. This lighthouse is 40 meters high, right? This is the top of the lighthouse, this is the bottom of the lighthouse. Here's a boat out here in the water. It says a sailboat is sighted having an angle of depression of 44 degrees. So be careful. This time my angle of depression is on the outside of my right triangle, right? Think of the person in the lighthouse looking straight ahead and then looking down to the sailboat. So that what angle did their eyes shift down or their chin shift down to look at the sailboat? That would be 4 degrees. Which means if we follow this Z down, this angle of elevation here in the bottom right corner would also be 4 degrees. So how far from the lighthouse is the boat? We're trying to find this distance. Well, once again, if you notice, this is my opposite, this is my adjacent. We're using tangent again. So tangent of 4 degrees equals 40 divided by x. Because my variable's in the denominator, I switch places. So x equals 40 divided by tangent of 4. You should plug that in and get about 286 meters. And finally, number 3, a driveway has a 15% grade. Okay, what does this mean, 15% grade? That slope is 15 over 100, right? 15% is 15 over 100. Well, we could reduce that, or you could leave it like that. But if we reduce both things by 5, so we get 3/20. What is the angle of the elevation of the driveway? So 15% grade. That is a slope I just said. So if that's a slope, that means my rise is this portion here, my vertical change, and my run is this portion here, my horizontal change, right? So it's your rise over run. And that's 3/20. So there I have it. So then the question asked, what is the angle of elevation? The angle of elevation, well, that's down here in this corner. So I'm trying to find this measure of angle A. So again, I have tangent of angle A equals 3/20. How do you find an angle? You always do the inverse trig, the inverse tan of 3/20. So remember on your calculator, you do the inverse tan, tan's the -1 of 3 divided by 20, and you push Control Enter, and I can see that the angle of elevation is about 8.5 degrees, or about 9 degrees. Okay, then it says if the driveway is 12 meters long, about how much does it rise? So now this is changing our perspective. If our driveway is 12 meters long, so now that we know, so I'm drawing another picture. The driveway is this portion here, right? That's this. So if the driveway is 12, what is its rise? Well, the rise is a vertical change. That's this over here. The angle doesn't change, so I could put in 8.5 degrees, or whatever you had over here on your calculator. Or maybe put in 9 degrees if you approximated to that. That would be fine. So what would your new trig function be? That should be tan of 8.5 equals x over 12. Is that tan? No, Mrs. Leopold has that wrong. Sorry to confuse you. Look at this. This is my opposite. This is my hypotenuse. Which trig function represents or relates opposite and hypotenuse to each other? Hopefully you're saying in your brain that is the sine function. Sine of this angle will give you equals opposite over hypotenuse. So over here I'll do it. Sine of 8.5 degrees equals opposite, which is our unknown, over our hypotenuse, which is 12. We're going to multiply 12 times sine of 8.5, and you should get somewhere around 1.8 meters. So let's try it. 12 times sine of 8.5. I think I have a typo here. "12 times sine of 8.5, and I get 1.77, so that is about 1.8 meters. And there you have it. Now you have a back page. Go ahead and try to work on that back page for extra practice, and then if you want to see the answers or know how to do some of them, then watch the next video because I will show you the answers on the next video. See you later.